Let us continue with vectors. This is the third video on vectors. In the last two videos, we discussed about what is vectors, what is scalars, then what are all the, what is equality of vectors, what is a physical quantity, then what is unit vector, what is zero vector. All these aspects we have discussed in the last two videos. In this video, I am going to discuss about the addition of vectors. So mainly parallelogram law. That's what I am going to discuss in this video. One important point you need to understand when we discuss about the addition of vectors is that in the last two videos I was telling repeatedly this point because it is very important. The first point is scalars obey the rules of algebra, but vectors do not obey the rules of algebra. That why they are not obeying? Because they are having direction. That's why they are not obeying the rules of algebra. Scalars do not have any direction, so they obey the rules of algebra. Now, for addition, multiplication, subtraction, for every operation, we have special rules for vectors. So 2 points I am going to cover in this video. One is the multiplication of vector by a scalar. That is a simple point. Now the addition of vectors by using triangular law, and parallelogram law is also there, where we will use triangular law and where we will use parallelogram law. That also I am going to discuss today. So mainly my focus will be on triangular law. So before getting into triangular law or addition of vectors, the first point I am going to tell you is multiplication of a vector by a scalar. Here the scalar is lambda. Lambda is the scalar. We are multiplying vector A with a scalar lambda, then lambda into modulus of vector A. That means, for example, if you have 5 Newton force in this direction, you are multiplying 5 Newton with one scalar, then the resultant should be, you are getting it, you have 5 Newton force, you are multiplying this 5 Newton, that is a vector, into a scalar, that is 2 is a scalar, then you will get the resultant as 10 Newton, 5 into 2, 10 in the same direction. If you are multiplying again this 5 Newton with, let me write it here, sometimes you won't be able to see this. So this you understood, 5 Newton. This is the practical example. Now I have again 5 Newton. You are multiplying it with minus 2. Then again you will get 10 Newton here, but the direction will be reversed because of the negative sign. This is the core concept you need to understand when you are multiplying with a scalar. The magnitude will be multiplied, but based on the positive, the number is positive or negative. If it is positive, the vector will be having the same direction. If it is negative, the direction will be reversed. So this is multiplication of a vector by a scalar. Next, we are getting into addition. Addition of vectors. Again, the point I am repeating. See why I am learning special rules for addition and multiplication, subtraction, all these operations. Why we are learning these type of special rules. The reason is vectors do not obey the rules of algebra because they are having the direction. That's why we are coming up with special rules for addition and multiplication. For addition, you have two rules. One is the triangular law. Then second one is the parallelogram law. Parallelogram law. So the point you understood, scalars obey the ordinary rules of algebra, but vectors won't obey the rules of algebra. So for addition, multiplication, everything we have special rules. For addition, we have two laws for vectors. One is triangular law, second one is parallelogram. Understood. Now, why we need two laws? See, for everything there is a reason, right? So why do we need two laws for this addition? That's what I am going to explain now. Now, if the vectors are in order, you will use triangular law. If the vectors are not in order, you will use parallelogram law. Again, I am repeating the points. See, you for vectors, there are two rules for addition. One is the triangular law, second one is the parallelogram law. If the vectors are in order, you will use triangular law. If the vectors are not in order, you will use parallelogram law. So what do you mean by the vectors are in order? Or what do you mean by the vectors are not in order? That's what I am going to tell you next. See, in order means, for example, you are adding two vectors, or you can add three vectors. Or first you consider you are adding two vectors. Those two vectors, if both the vectors are in clockwise direction, if they are clockwise means both of them must be in clockwise direction, then we will call those vectors are in order. If one vector is anti-clockwise, the other vector must be in anti-clockwise. Then also it is in order. See, for example, this is vector A and this is vector B. See, both of them are in clockwise direction. So these two vectors are in order. Now another vector. This is vector B and this is vector A. See, both the vectors are again in clockwise direction, right? So this is clockwise direction. This is also in order. Understood? So this is clockwise, this is clockwise. Now if it is like this is anti-clockwise, right? That's also in order, because this is anti-clockwise, but both the vectors are in anti-clockwise. So these three pairs of vectors are in order. Here these two vectors are anti-clockwise. The point is, if one vector is anti-clockwise, the other vector also must be anti-clockwise. If one vector is clockwise, the other vector also must be clockwise. Then the vectors are in order. If they are not in order, so how do we understand that? So that's what I am going to tell you. For example, if you have one vector in this direction and the other vector in this direction, so this is clockwise and this is anti-clockwise. Vector A is clockwise and vector B is anti-clockwise. Then they are not in order. So if they are not in order, we will go for parallelogram law. If the vectors are in order, we will go for triangular law. Understood? Then another case, if one vector is like this and another vector is like this, this is vector A, this is vector B. This is not in order. Here also you will go for parallelogram law. So if the vectors, if both the vectors are in clockwise direction, or if both the vectors are in anti-clockwise direction, the vectors are in order, then we will go for triangular law. That is the summary. What is the summary? If both the vectors are in clockwise direction or both the vectors are in anti-clockwise direction, then we will go for they are in order and we will go for triangular law. The next point is, if one vector is clockwise and another one is anti-clockwise, then they are not in order and we will go for parallelogram law. Understood? Now I am going to the next point. So in addition, there are two laws. One is triangular law, second one is parallelogram law. So my next point what we are going to discuss is, what is triangular law of addition of vectors. Okay, so what is triangular law of addition of vectors? See, as we discussed, if two vectors are in order, this is vector A and this is vector B. See, from this is the starting point and this is the ending point. These two vectors are in order, both are in clockwise direction. See, this is the arrow. This is in this direction, this is in this direction. These two vectors are in clockwise direction. What is triangular law? Triangular law means, see, let us consider this as displacement. You may be familiar with distance and displacement. You learned it in the 9th grade and 10th grade. So what is distance and displacement? Distance is a scalar quantity and displacement is a vector quantity. Distance is the change of position of a particle in any direction. Displacement is the change of position of a particle in a fixed direction. You know it. See, let us consider displacement, because displacement is the vector quantity. So we are dealing with, we are discussing about the vectors addition and multiplication, all these things. Let's consider as this vector as displacement. See, we started from here and we travel and reach this point. We reached here. After that, we are again going in this direction and we have reached this point. That means this vector A plus vector B, I can complete this triangle and give this direction in this direction. So starting from this point, let me say it as P, and this is Q and R. So we are taking this part PQ and then QR, that is vector A and vector B, that is equal to PR. This is vector A plus vector B. That means if you complete, that is triangular law. If you complete the triangle and give the direction in the opposite order, this is in clockwise direction. These two vectors are in clockwise direction, but vector A plus B is in the opposite order, that is anti-clockwise. This is anti-clockwise. This is anti-clockwise. Understood? This is clockwise. A is clockwise. B is also clockwise. So the sum will be in the anti-clockwise direction. That means in the reverse order. So from this, what we understood is, if two vectors are in order and they form the sides of the triangle, then the sum will be the side completing the triangle. Understood? So what is triangular law? If two vectors are represented in magnitude and direction, because this is a law, so that statement you need to understand. Law, every law it's having, Newton's law, or when you learn gravitational law or Coulomb's law, all laws, it is having a exact form of sentence, so you need to learn that. So what is triangular law means? if two vectors, that is PQ, our vector A and vector B, are represented in magnitude and direction by the sides of a triangle. These two are the sides of the triangle PQR. By the sides of a triangle taken in order. They are in order. I told you, they are both of them are in the clockwise direction. Taken in order. Then the sum is represented in magnitude and direction by the third side of the triangle, that is PR, taken in the reverse order, taken in the anti-clockwise direction. These two are clockwise, taken in the reverse direction. You can write it down. Write down the, if you have a notebook, you can write down this statement. So this law, like this, you need to, if in the board exam, if you are getting this question, you need to write it like this. So what is triangular coordinate addition of vectors? If two vectors are represented in magnitude and direction by the adjacent sides, adjacent means close sides of a triangle, taken in order, then the sum is represented in magnitude and direction by the third side of the triangle taken in the reverse order, because these two are clockwise. Then the sum will be in the anti-clockwise direction. Understood? So I am summarizing the points we discussed today. First is multiplication of a vector by a scalar. You need to just multiply with that number. For example, if I am multiplying 5 Newton force, we already discussed 5 Newton with into 2, then you will get 10 Newton in the same direction. If you are multiplying with minus 2, then the opposite direction. That's all. That's what you need to understand. If the sign is negative number, means the direction will change. Understood? Now, that is one point we discussed. After that, for addition, there are two laws. One is triangular law and another one is parallelogram law. Triangular law we will use when the vectors are in order. Parallelogram law we will use if the vectors are in opposite order. Got it? Now, what is in order? In order means both the vectors must be clockwise, or if the vectors are anti-clockwise, both the vectors must be anti-clockwise. Then those two vectors are in order. See, these two vectors are order, clockwise. If it is in the anti-clockwise direction, both the vectors must be anti-clockwise. Then not in order means if one vector is clockwise and the other vector is anti-clockwise, then we cannot use triangular law. At that time, we will use parallelogram law. Then finally, we learn triangular law. This is the. So what is the statement? If two vectors are represented in magnitude and direction by the adjacent sides of a triangle taken in order, this is clockwise, both of them are clockwise, that is in order, then the sum is represented in magnitude and direction by the third side of the triangle taken in the reverse order, that is anti-clockwise. Sum is anti-clockwise. Understood? That's all. That's all for today. Thanks for watching. Thank you.